Hello everyone, my name is Thanh Nguyễn. I would like to introduce to you my project, design and manufacturing a multi-terrain and water-resistant unmanned ground vehicle. As we know, the unmanned ground vehicle has been designed with many different ideas and many shapes to suit the requirement of its specific environment. The main purpose of the UGV to exploit and do small mission in place that is dangerous to human life and health. UGV design must be achieved the goal of being autonomous, especially standing up when the falling, and it can be worked in many environments as possible, like in water or dust. Besides that, to simplify the controller is needed to make it possible for everyone to use. Highlight from related work. The design of the UGV was inspired by the micro-flip robot of the Yang 1. His robot can flip itself to climb the stairs. The main mechanism for the robot to flip over is the support arm, which is located in the center of the chassis and is controlled by the rotating shaft. At the same time, with the symmetrical design of the body, it also has the robot to work when it's in the upside-down position. The objective of this project is to design and manufacture UGV with the most efficient on terrain. The robot should be able to turn itself from the upside-down position, climb the obstacles such as the ladder and the stair. The ability to perform on these tasks are the construction of the limb and the shape of the wheel, which give the robot more range and freedom to move. Requirements for the robot include light enough to be carried by a single person, easy to control, doable, and must be able to reach the speed 5 meters per second and range up to 500 meters. Deliverable. The first deliverable is 3D printed prototype of the robot's body. The second deliverable is 3D printed prototype of the motor housing. The third delivery is 3D printed prototype of the controller with Raspberry Pi antenna and LCD holder. Evaluation metric. The success of the project is focused on design of the robot to achieve the lightweight for the single person carry, reach the speed of 5 meters per second, and the range up to 500 meters. The robot must be resistant to water and dust according to the IP57. The success is also done in the interaction between the user and the robot through the controller, include stability and easy to use. Methodology, the approach. SolidWorks will be used to build the robot model. It includes a feature like mechanical simulation, determining the center of gravity, mass and volume, and set up the detailed drawing for assembly. ANSYS will also be used to optimize the structural design. It's used to calculate the bearing capacity of the material. After completing the design, rapid prototyping of the model will be carried out through the broadest machine available at the university, such as 3D printing, laser cutting, and sheet metal. In parallel with the rapid prototyping, controller programming and circuit fabrication will be conducted. Designing the model. The first step will develop the model through the SolidWorks. It given an overview of the location of the joint and the leg. With the leg can be turned 180 degrees and symmetrical body to have the operate in the upside-down position. In the next step, it will be used simulation from the SolidWorks to reproduce the robot behavior in case like overcoming large obstacle, stair. The last step will determine the material, size, and the weight of the necessary components such as the battery, circuit board, and motor for necessary space inside the robot. We will try to make the body small as possible. Water and dust resistance of the body and motor joint. To ensure the robot can operate in the water and dusty environment, the body and joint and electronic component must be protected. For the body, a gasket will be used to protect internal component. Gasket can be made of the silicate, which ensure the flexibility and suitable for the high and low temperature. For the motor outside of the body, a housing design is needed to protect the motor from the water and the dust. The motors will be placed in the seal box with a lip. The body and the housing will be designed with a groove suitable for the flexible O-ring. The motor shaft will be guided through the long pipe wall and sealed by the two ends of the O-ring and grid. Development of the controller. The controller will be used in Raspberry Pi. The microprocessor is equipped with the 2.4 GHz Wi-Fi interface to be able to communicate with the Arduino inside the robot. The Raspberry Pi also supports the connecting to the wireless camera and can output the image through the HDMI port. The controller will be used to program in two modes. The automatic mode that functions are pre-programmed, and the manual mode will be allowed and have the user to fine-tune the operation. Resources needed. On the software like SolidWorks and ANSYS are free by student version. Some electronic and mechanical components need to order and fabricated. The cost of the whole project is estimated from $1,100 to $2,700. Anticipated challenges. The first trick is the manufacturing and prototyping stage, since the machine shop equipment at the school is limited. Besides that, the COVID pandemic made the shipping time longer and the cost higher. Preliminary work. At the time of proposal, the first deliverable completed were the CAD model of the robot. The driver gear and the shaft mechanism are made principle to have the leg rotation. The step motor with a gearbox is used to control the angle of the leg. Obstacle traversal demonstration. According to mechanical simulation from the SolidWorks, the leg can rotate 100 degrees, helping the robot to stand up. Follow those steps in the figure 7. The rotatable leg also have to lower the robot's height to able to overcome the narrow gap, climb narrow wall, or high step. Significant. The impact for the UDV to be an affordable and efficient customizable platform for various aftermarket payloads and local motion accessories. Benefit company by providing a safe and cheap alternative to human insanity in location or situation.